Remember our governor limits from earlier: 100 queries, 150 saves, 10 seconds of processing time, all per transaction. Here's the problem. What if the hospital needs to update 1 million patient records overnight? That's way beyond what fits in those numbers. You literally cannot do it in one normal transaction. This is exactly why Salesforce gives developers special tools called Async Apex, ways to run code that gets its own separate set of limits, completely outside the normal rules. The simplest async tool is the future method. Think of it like telling a coworker, "Hey, take care of this later. Don't make me wait." For example, when a patient is discharged, instead of making the doctor wait while an email slowly sends, we mark that email sending method with @future, and Salesforce runs it in the background, completely separately, so the doctor's screen doesn't freeze. One limitation to remember: you can only pass simple values into a future method, no full records, just basic things like an ID or a number. Queueable Apex does almost the same job as @future, but it's smarter in two ways. First, you can pass in real records, not just simple values. Second, it gives you back a job ID so you can actually track whether it finished, and it can even start another queuable job right after it, like a relay race. If @future is a quick favor, queueable is a properly tracked task. Now, what about that 1-million patient record problem from earlier? That's exactly what Batch Apex is built for. It has 3 parts. Start: gather every single record you need to process. Execute: this runs automatically over and over, handling just 200 records at a time until everything's done. Finish: runs once at the very end. Perfect for sending a job complete summary email. It's like processing a giant pile of laundry one small load at a time, instead of trying to shove it all into one washing machine. Finally, Scheduled Apex simply runs Apex code automatically on a timer, like an alarm clock that triggers your code instead of waking you up. A very common pattern. Scheduled Apex wakes up every night and kicks off a Batch Apex job to actually do the heavy lifting. One decides when, the other handles the how much. If this sounds familiar, yes, it's the code version of the scheduled flow you learned earlier. Let's talk about how Salesforce connects to other systems like an external lab or a billing service. Imagine you're at a restaurant. You don't walk into the kitchen yourself and start cooking. You tell the waiter what you want, and the waiter goes and gets it for you. An API works exactly like that waiter. Salesforce doesn't need to know how the lab system stores its data internally. It just asks the API for what it needs the same way every time. The most common type of API today is REST. It speaks a simple format called JSON, and it uses everyday action words you'll recognize. Get to read data, post to create something new, put or patch to update something, and delete to remove it. If you've ever used a website, you've triggered REST calls without even realizing it. This simplicity is exactly why most modern integrations, including most of what you'll build, use REST. SOAP is the older sibling of REST. Where REST is like a casual, flexible conversation, SOAP is more like a strict legal contract. Everything has to be spelled out in advance using a rigid format called XML. You'll mostly run into SOAP when connecting to older, established enterprise systems, banks, insurance companies, government systems that were built years before REST became popular. Here's a rule you should never break. Never type a password or web address directly into your Apex code. Why? Because anyone who can see your code can see that password too. And if the address ever changes, you'd have to hunt it down in every single class. Named credentials solve this by storing the address and login details safely in one place, outside your code. Your Apex just references it by a simple name like hospital_billing_API, and Salesforce handles the secure part behind the scenes. Before any system lets you in, it wants proof of who you are, just like showing your ID at a building's front desk. There are a few common ways to prove this. An API key is like a simple secret password sent with every request. Auth 2.0 is a more secure handshake, where you get a temporary access pass that expires after a while. And there's also basic auth, which is just a username and password sent together, simple but a bit old-fashioned now. Different systems accept different forms of ID, and named credentials can store any of these for you. A callout simply means Apex reaching out to the internet to talk to another system. It's just 3 steps. Build the request, tell it where to go and what you want, send it, and read whatever comes back. That's genuinely the whole idea, Everything else we'll cover is just filling in the details of those 3 steps. Integrations actually go in 2 directions. An outbound callout is Salesforce reaching out, like checking a shipping company's API to see if a delivery has arrived. An inbound REST service is the opposite. Salesforce opens up its own little API, using something called a REST resource, so that other systems can call into Salesforce. Same conversation, just 2 different directions it can flow. Here's something important. APIs don't understand Apex objects directly. They only understand plain text, in a format called JSON. So before you send anything, you have to convert your Apex object into that text format. This is called serialization. Think of it like packing a suitcase before a trip. Your belongings need to fit a format that can actually travel. JSON.serialize does exactly that conversion for you, automatically. Deserialization is the exact reverse, unpacking the suitcase once it arrives. When the lab system sends data back, it comes as plain JSON text. Your Apex code can't use that text directly, so you convert it back into a proper Apex object using JSON.deserialize. You'll usually build a simple wrapper class first. Remember those from Apex Advanced? Shaped exactly like the JSON you're expecting, so Apex knows where each piece of data should go. Let's put the whole thing together with one real example. Our hospital needs to send a patient's lab sample ID to an external lab system and get the results back automatically. Step 1. Build the request using our safely stored named credential. Step 2. Serialize the patient data into JSON. Step 3. Send the callout. Step 4. Deserialize whatever JSON comes back into a wrapper class. And step 5, actually use that data, for example, automatically saving the lab result onto the patient's record. That's a complete, real integration from start to finish.